Alright, hopefully you're watching this video after you've completed the problems on page 27 in problem 2.4. I'm going to go over how to do a couple problems, and then you can check your answers. If you have any questions, make sure you get them answered now. And just remember, folks, I'm always watching you. Ooh. So let's dive on into letter A. I've split this page into 4 boxes, so I'm going to go over 1, 2, 3, and 4 of letter A. So just as a reminder, in this experiment, you're tossing 3 coins, and you're going to determine how many times are all 3 coins going to match, and how many times are they not going to match. Problem A wants to know how many possible outcomes there are. Well, I could draw a tree diagram where I'm going to list out my heads and tails, and based off of each of those events, go from there. I could do that, and I could find out how many possible outcomes there are, but I'm going to take the shortcut method. The shortcut method is going to be to list out, I have 3 different events that are going on. I'm going to flip a coin, 3 different coins. So in my first coin, I have 2 different outcomes. In my second coin, I also have 2 different outcomes. In my third coin, again, I'm going to have 2 outcomes. 3 coins, all with 2 different outcomes. The easiest way to solve this problem is to take 2 times 2 times 2. That is going to leave me with 8. 8 possible outcomes in this experiment. The last part of question 1 asked me, are the outcomes equally likely? Yes, I do have the same chance of getting a heads, a heads, a heads as tails, tails, tails. All of the outcomes, the coin landing in order, are equally likely of happening. Now I'm going to take a look at problem 2. Problem 2 asks me, what is the theoretical probability that the 3 coins will match? Well, I'm going to set this up into fraction form. Again, we're looking for 2 numbers. The top number is number of times the coins will match. So I'm going to put match up top. And the bottom number is going to be the total outcomes. Well, in problem 1, we talked about the total outcomes. It was 8 total outcomes. Now we got to figure out how many times am I going to match 3 coins together. If you think about it, there's only 2 different ways to match 3 coins together. Heads, 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 and tails, tails, tails. There are no other ways to match 3 coins together. Therefore, my theoretical probability is 2 out of 8 times. Question number 3 asks us, what is the theoretical probability that exactly 2 coins will match? Well, if we think about it, we got to try and figure out all the ways that we can have only 2 coins match. So again, I could think about listing out all the possible outcomes when I flip 3 coins. But here's what I'm going to do. I'm going to think about this problem and say to myself, well, I know 2 ways where there are not going to be only 2 coins that match. We looked at them up here. Heads, 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 tails, tails, tails. Those 2 examples have 3 of the same number. In problem 3, we're looking for only ways where 2 coins match each other. Out of the 8 total outcomes that we talked about in this problem, 2 of them have the heads, 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 tails, tails, tails. All of the other outcomes are going to have only 2 coins that match each other. Therefore, our answer to this problem is 6 out of 8. 6 out of the 8 times 2 coins will match each other and the other one will be different. The other 2 times, all 3 coins will match each other. Question 4 wants us to evaluate, is this game fair? Well, if you remember right, the directions of the game were Santo wins when all 3 match. TV wins when not all 3 match. Is this fair? Well, if you look at problem 2, 2 out of 8 times all 3 coins will match each other. In problem 3, we looked at all the different ways that 3 coins will not match. Are 2 ace and 6 ace fair? Of course not. No, not fair. Poor Santo. Letter B says, if you toss 3 coins 24 times, how many times would you expect 2 coins to match? Well, if we remember back to problem 1, number 3, we determined that 6 out of 8 times those 3 coins will have a no match. So if we did this 24 times, how many times would we expect the no match to occur? Right now, I have this problem set up as an equivalent fraction problem. 6 ace is equal to how many 24s? Here is my equivalent fraction problem. 6 ace, how many 24s? Well, 8 goes into 24 3 times. You need to multiply both sides by 3, and I end up with 18. 18 times I would expect 2 out of the 3 coins to match. Looking at the very last problem, Santo said, it is possible to toss 3 matching coins. TV replied, yes, but is it probable? What do you think each boy meant? We're going to take a look at really quickly at possible versus probable. Possible means it can happen. Can that event happen? Does it have any chance at all of happening? Probable means it is likely to occur. Another way to look at it is, does it have better than a 50% chance of happening? In this problem, if we toss 3 coins, do they have a better than 50% chance of matching? If you recall, our probability was only 2 out of 8, or 25%. Is it possible? Yes. It can happen. Is it probable? No. It is unlikely to toss 3 coins together and get them to match. That concludes the problem section for 2-4. Now that you are completely finished, it's time for you to start on your assignment. Tomorrow, which is Wednesday, you are going to hand in all of the homework pages from Investigation 2, 2.1, 2.2, 2.3, and 2.4. Staple them together and hand them into the math basket.